So let's start with the experiment of spherometer. So what is the aim of spherometer? So first of all, spherometer is this instrument. This is the spherometer. Now the aim of the experiment is to determine the radius of curvature of a convex lens. So what is first of all radius of curvature? If there is any curved surface like this, so if there is any curved surface, if I can draw a circle such that that curved surface is part of that circle, then the radius of that circle is called as radius of curvature. Now the radius of curvature formula you can see here, and the principle is based on the micrometer screw. That is the principle on which this experiment is based, and the formula is given by R, capital R, which is radius of curvature, equal to L square divided by 6h plus h by 2. Now what is h? H is called as the sagitta. I'll tell you what it is later. Now what is L? Now the distance between these two legs is L. So basically these three legs, 1, 2, 3, these three legs are supposed to form an equilateral triangle. So if I make an impression like this and then draw a triangle and measure its length using scale and take an average, that will give me L. Now what is for H? The formula for H is NP plus X into least count. LC means least count. So N means the number of complete rotations, so it can only be an integer. P is the pitch of the spherometer, which is always 0.1 centimeter. Now pitch means if you rotate the disc exactly once, this disc will move up or down on this scale by certain distance. So that distance is called as pitch, and it is always 0.1 centimeter for all spherometers. So X is A minus B or 100 plus A minus B. I'll tell you what it is later. And least count is same as screw gauge, which is 0.001 centimeter. Now diagram should come here. Now what is the observation table looks? This is how the observation table looks like. So on convex lens A, on flat surface B, then X, then N, X and H. Now how to start the experiment? So first of all you have to keep the convex lens, and then you have to keep the spherometer on top of the convex lens. For this you have to make sure that the middle leg is not touching the convex lens surface. So for that you have to make sure that the middle leg is not on the same level as the other three. That you can achieve by rotating the, basically there should be a gap. So you can see that there is some gap between the middle leg and the flat surface. So that gap should be there, so that when you keep it on the convex lens, the middle leg doesn't touch the optic center of the lens. Now what you have to do, you have to hold the convex lens like this. You have to hold the convex lens and rotate the spherometer without applying too much pressure. Now when the middle leg touches the convex lens, you are holding the lens, remember, so lens cannot rotate. So what will happen? The spherometer will itself rotate. So it's like this. So I'm rotating the lens now. I'll hold the lens and I'll start rotating. Now I stopped because the spherometer rotated. So when the spherometer gives a jerk or rotates, you have to stop, and then you have to keep it carefully on the flat surface. So you can see now that the circular division which is coinciding with the vertical scale, you have to see. So for it is around 76, 77. It's between 77 and 78. You take the lower value, that is 77. So 77th division on the circular scale is coinciding with the vertical scale. So that is my value A, 77, because I kept it on the convex lens. Now without turning anything, keep it on the flat surface. This is flat enough. Again turn it. Remember that 77 is your new zero, new reference point. If 77 passes the vertical scale again, number of completed rotations would be 1. So I'll start it now again. 20, 10. Okay, it turned. So what is the reading now? It's around 92. So it's 92. So basically I didn't reach 77. So if I continued to turn, maybe it would have reached 77. but before that only the middle leg has touched the flat surface. So number of complete rotations would be 0, and x is a minus b, but a minus b is negative, you can see. So I have to use this formula, which is 100 plus a minus b, which is basically 177 minus 92, which is basically 185, sorry 85. Okay, so now what is h? We already have the formula here. If you substitute, we will get 0.085 centimeter. That's my h. Now if I substitute back in this formula, the first formula, r is equal to L square, I will get the radius of curvature. So let's do the calculation for that. So r1, L is 3 centimeter. Basically I have measured the distance between any two legs, so it's around 3 centimeter. So I'll get 9. Actually it's 3.1, 3.2, so you have to measure it perfectly. So 9 divided by 6 into 0.085 plus 0.085 by 2. So because the formula is L square by 6 into h plus h by 2. So actually the L square value came out to be 3.1. L was 3.1, so L square is 9.61 centimeters. So I have substituted everything, and this is the radius of curvature of the lens. So now you are supposed to do one more reading. You have to take one more reading, then take the do the calculation again and take the average. That would be your result.